So today we're going to be working with exponential word problems. So let's read this first example. It says, based on the data from the last 50 years, the world population can be approximated by the function g of x equals 2.5 times 1.1085 raised to the x, where x equals 0 corresponds to 1950. Now just before we go on to finish answering this question, I want to make sure that we understand what this formula is saying. So this formula is 2.5 times 1.1085, and that's raised to the x power. So this little triangle caret thing means raised to the x. Okay? So what we want to do is we want to estimate the world population in 2015. So what we're going to do is we're going to take our formula, g of x equals 2.5 times 1.1085 raised to the x power, and we're going to figure out what we want to figure out the world population in 2015. Now, in our problem, it says that x equals 0 corresponds to 1950. So what we have to figure out is we have to figure out what we're going to plug into our equation. So to do that, we have to figure out a value for x. Now, our value for x here is going to be some year. Now, you might think we're going to plug in 2015, but if you look carefully, it says we're looking where x equals 0 corresponds to 1950. So that means 1950 corresponds to 0. 1951 would correspond to 1, and so on. If we had 1952, it would be 2. So we have to figure out the years that have passed since 1950. So the way we're going to do that is we're going to subtract 1950 from 2015, and that's going to give us what our x is. So 2015 minus 1950, that's going to be 65. So I know that our x is 65 in this problem. So we're going to figure out what is g of 65, and we're just going to get that's 2.5 times 1.1085 raised to 65 power. And when I plug that into my calculator, that's going to give me the answer of what the world population will be in 2015. And when I plug in the calculator, I get that that's 20,021.9. Now that's going to be what our world population is in 2015. Now let's look at part B. It says, in what year will the population be double what it is in 2015? So in 2015, we know that it's 20,021.9. So we want to figure out what would equal 4,043.8, because that right there is going to be double our world population in 2015. So the way we're going to figure that out is we're going to take that, and that's going to be our g of x. So I'm going to take this number, this 4,043.8, and I'm going to erase all this other stuff. So just a second. We had our 40,043.8, and I want to figure out when will this formula equal that 40,043.8. So I'm going to have 40,043.8, and I want to know when does that equal 2.5 times 1.1085 raised to the x power. Now what we can do is we can try a couple different values for x. And what we're going to have to do is we're going to have to guess. So let's see. I know it's going to be past 2015. So I'm going to say, let's try x equals, let's try x equals 100. So if I put 2.5 times 1.1085 raised to the 100, let's see what that gives me. Okay, and that gives me that 74,389. Now that is way too big, right? That's way bigger than the number that I want to get. So what I'm going to try is I'm going to try a little bit smaller. So why don't we try x equals, let's say 80. X equals 80. So 2.5 times 1.1085 raised to the 80. And that gives me 9,479. So I'm getting a little bit closer. So what I'm going to do is I'm going to try a little bit smaller now. So what if we do 1.1085? What if we try it to the 70? So when we try it to the 70, we get 3,384. So that's a little bit too low. So now I know that my number is going to be between 70 and 80. So when I try numbers now, I'm not going to choose any number less than 70 or greater than 80. So what I'm going to do is I'm going to erase all this, and we're going to try a number that's somewhere between 70 and 80. So remember, I'm trying to find some number that will multiply to give me 4,043.8. So what if I tried 72? So 2.5 times 1.1085 raised to 72. And when I plug that into my calculator, I get 4,158.2. And so that number is really close to my 4,043. So I know that my x is going to be 72. But remember in our problem that 72, that represents the years since 1950. So what I have to do is I add 72 to 1950, and I get 2022. So that means in the year 2022 that my population will be double what it is since 2015. Now we also today have to talk about what the number E is. So the number E. So we've talked about E before as being this irrational number, but what we know is that E equals 2.7182, and that goes on forever. It's an irrational number that doesn't repeat. Now this E is known as the exponential constant. Exponential constant. It is a number that's used in many exponential problems. So we're going to look at an example where we use this in a problem. So let's look at this example. It says if the population of the U.S. continues to grow as it has since 1980, then the population in year t since 1980 will be represented by the equation P of t equals 227 times e raised to the 0.0093t. What will the population of the U.S. be in 2020? Okay, so what I want to do real quick, I just want to rewrite my equation. P of t equals 227 times e raised to the 0.0093t. Okay? Now remember that this t represents years since 1980. So the question it's asking me is what will the population of the U.S. be in 2020? So I want to know in 2020. So 2020. Now remember, this is the year since 1980. So to figure out what my t is going to be, I have to subtract 1980 from 2020. And that tells me that my t is going to be 40 for the time. Because 40 years have passed since 1980. Sorry about the sirens. So what I'm going to find is I'm going to find P of 40, and that's going to tell me what the population is going to be in 2020. So that's 227 times e raised to the 0.0093 times 40. And when we enter that into our calculators, we get 329.29. So that's going to be the population of the U.S. in 2020. It's 329.29. And remember, the way we figured that out was we had our exponential equation here that tells us the population of the U.S. in billions since 2020. We figured out that 40 is going to be our time. So we took that 40, we plugged it into our function, entered that into our calculator, and got 329.29. So in these exponential word problems, you're going to be given exponential functions that have uses and applications in population growth, in exponential growth or decay, and you have to figure out what to plug into your formula in order to get out the answer that you want.